All right, guys, so this is the first chapter 3 foldable we're doing. So what I want you to do is get out these two papers. They go together. So you want both of these papers. And then what we're going to do is, just like the directions say down here, we're going to cut out the dark black lines, okay? So this side and this side will be separate. This side and this side will be separate, and then this square down here will be separate of itself. So you should have 5 separate things when you go and cut out along the dark lined, bold black outlines. All right, so when you're done cutting, you should have 5 sheets. You should have this sheet here. Kind of this is by itself. We'll just paste that in a little while. I'll tell you what to do. And then you should have each of these, which is an individual sheet. See, all of these are individual sheets. And when we do our foldable, you'll put them like this, such that each tab is in order on the bottom. Okay, and then when we're done, you'll just put a couple staples up top and it'll stay together before we put it in our interactive student notebook. All right, let's go ahead and start writing on some of these. Some of these may be review or should be reviewed from Algebra 1, but some of them may be new concepts, so that's okay. So parallel lines are lines that are coplanar, so they lie on the same plane, but they never intersect. Can't spell here, but they never intersect. Okay, so they're coplanar, but they never intersect. So if we look at these two lines, they lie on this same plane here, but they never ever intersect each other. Okay, so perpendicular lines now, guys, you should know this. These are two lines that intersect at a right angle. Okay, that's what this box here means. That means this is a right angle. So any two lines that intersect to form a right angle, that means those two lines are perpendicular. All right, skew lines. Now kind of write kind of small because we're going to add down here coincident lines. Okay, so try to keep some room after skew. So skew lines, they are lines that are not coplanar. So they're not coplanar, and they never intersect. Okay, this diagram can be a little bit confusing because when we look at this, it looks like they intersect at this point here. But really they don't. Think of this as like maybe this line is below this line, which is on top. So maybe in space, like if you're looking down or looking up, they look like they cross, but if you get really close to them, there's actually space between them and they really don't intersect. All right, coincident lines are two lines that lie directly on top of each other. Okay, so suppose you have a line that looks like this. Okay, well maybe there's another line that's right on top of it. It's supposed to be right on top, guys, that looks like this. That would be coincident lines. All right, now let's go to the next page of our foldable. All right, so we're going to look at this box, and this is just a right rectangular box, or whatever you want to call it, prism, right rectangular prism. We want to find everything that satisfies these equations here. So, one, it says name 3 lines parallel to EH. Okay, this line that I highlighted is line EH. Okay, so we want 3 lines that are parallel to this. Well, one line would be AD, which is right here. Line AD. And the reason that's parallel is, think of this right here. This would be a plane. Okay, so that would be 1. What about this line back here, FG? Okay, so think if we were to talk about this plane here, right? They are on the same plane, this one highlighted, but they would never intersect. So that would mean they're parallel to each other. And this one seems kind of odd, but an answer to this would also be BC. Okay, now the reason BC is some of you are thinking, well, that's not on the same plane. Well, think if we drew like from here to here and from here to here, like a diagonal. This would be one plane. Okay, then these two lines would be on the same plane, but they would never intersect. All right, now let's look at number 2. So are any of these lines parallel to each other? Well, they're all parallel to each other. So all parallel to each other. All right, let's look at this next question. So it says, what is the relationship between BF, so BF would be right here, and DC, which is right here? All right, if we look at these, we could continue these out forever and ever and ever, and they would never, ever, ever intersect. Okay, so that means they're either parallel or they're skew. Now, are these two red lines here on the same plane? No, they're not on the same plane, so if they're not coplanar and they never intersect, that means they are skew. All right, name a line that's skew to AE. Okay, so AE is right here, straight up and down here. A line that's skew to AE. So we want a line that's not coplanar with it, but will never intersect it. So guys, there's several things that we could write here. There's several lines that are skew. I don't know, wouldn't GH be one? So GH would be one. Try to think of a few more. So GH, what about DC? DC would be another. What about FG? FG would be another. I know it says only one. Any of these would work. What about BC? Okay, BC would be another. We could keep going. Okay, but those 4 lines would be skewed to line AE. All right, so if we look at the next question, it says name a plane parallel to plane EFG. Okay, now we want to highlight EFG so we know what it is. So if this is like a box, think of that as the bottom of the box. So a plane that's parallel, it will never intersect it. Wouldn't that be this top box right here? And remember, you have to pick any 3 of these points to name the plane. So we could say plane, I don't know, we'll make it easy. Let's just say plane ABC is parallel to the other plane. All right, so the next question says, name a plane that contains E, so E is right here, contains this point, that is parallel to plane BCGF. Now they only needed three of these points, but that's okay. We'll forgive them this time. So BCGF. So we're looking at this plane right here. So we want a plane that contains this point E that is parallel to this purple plane. Okay, so what plane would that be? Right, it would be this plane right here. Okay, so we can name that, we can name it several different ways. Let's just call it plane ADH. All right, so the next question says, name a line that's perpendicular to GH. So GH is right here, so we want a line that's perpendicular to this line, so it crosses it in 90-degree angles, that contains point T. Okay, it contains point T. So here's T. So what line would be perpendicular to this black line that contains this point? Okay, wouldn't that be this line right here? Okay, so I could say CG or TG or GT or GC. Those are all the same, just named differently. All right, so last one. It says, name a plane that's perpendicular to plane AKEH. So AKEH, it's talking about this plane. We want a plane that's perpendicular to this. Okay, so I'm going to pause this. I want you to try to find it. Now, I will tell you there's more than one plane. Okay, you only have to name one plane, but I challenge you to name as many as you can. So I'm going to pause this. I want you to try, and then we'll go over it. All right, so it's perpendicular to it. So wouldn't this plane right here be one of them? Okay, so that would be what? Plane DCG? That would be one. Wouldn't this one right here also be perpendicular? Okay, because notice this would be a right angle, and this would be a right angle. So I could name that plane, what, ABF? What about this plane up top? Okay, because this would be a right angle. So I could name that plane ABC. And then last but not least, what about this plane right here? Because this is a right angle. Okay, so that would be plane FGH. Now, any of these would have worked. I know it only says one, but any of these would have worked just fine. All right, guys, here's a couple postulates. Now, we're not going to use these a whole bunch like we use some of the other ones, but our book does mention it, so we need to mention it here too. So the parallel postulate tells us if there is a line, so we have this line here, and a point not on the line, so we have this line and this point that's not on the line, then there is exactly one line through the point that's parallel to the given line. So what this tells us is we can only draw one line, okay, that's parallel to this. So if these two are parallel, that means if these two are parallel, that this line can't be parallel to it, this line can't be parallel to it, this line can't be. There's only one parallel line that we can draw through this point that's going to be perpendicular to this line. Okay, so same scenario applies for down here. So the perpendicular postulate, if there is a line and a point not on that line, then there's only one line that we can draw from this point that's going to be perpendicular to this line. Okay, so if this line is perpendicular here, then we can draw a million lines from this point, but this one won't be perpendicular. This one won't be, this one won't be, this one won't be. There's only one perpendicular line we can draw from this point to this line. All right, guys, here in a minute, I'm going to show you how to glue this in, but we're going to glue this in on the same page as the other foldable, but kind of a little bit down below it where you have extra room. And then we're just going to write on the outside how they are like and how they are different. Okay, so we're talking about skew and parallel lines. Okay, so skew and parallel lines are alike because they never intersect. So skew lines never intersect and parallel lines never intersect as well. The difference between the two is skew lines are not coplanar. However, parallel lines are coplanar. Okay, so that's how they're alike and that's how they're different. All right, guys, so if you look, this is how I glue it into my interactive student notebook. So as you can see, I have all these tabs that I can just lift up here, and then I've glued this down, and I have the writing that goes with it right here. So it should be pretty easy to follow.